I want to talk today a bit more about quantitative and qualitative and the distinction between the two, or the lack of distinction between the two. You may be familiar with that distinction, but that doesn't mean that doesn't need talking about, because it seems odd to me that in the age when we dismiss simple binaries, we still accept that there's a distinction, a sharp distinction between qualitative and quantitative. And what I want to say today is the boundaries are not so clear as all that. In very crude terms, quantitative is about numbers and qualitative is about, well, something else. But just because something is about numbers doesn't necessarily mean that it's quantitative. I was standing at a bus stop the other day and watching the countdown for the time my bus arrives. 8 minutes, 7 minutes, 6 minutes. That's quantitative, all right. But after a while, the bus didn't come. The bus stop resets to 10 again. Perhaps 10 is the biggest number it could cope with for how long the delay to the next bus was going to be, and it starts counting down again. 9, 8, 7. I did that several times, and I'm thinking several things about numbers. One is they're not always reliable. You mustn't think that just because something is a number, it must be reliable, any more than a bus is reliable. But it also occurred to me that before long, there was going to be a qualitative change. There was going to be a qualitative change. I was going to miss my train if the bus was long enough. It may only be the distinction between number 15 and number 16, but it was going to mean a qualitative change. There's a qualitative leap at some point when quantitative tips over into qualitative. And the other thing I wanted to say is that, well, qualitative is about something. We know it's about feelings, it's about attitudes, it's about opinions, but very often we will try and convert those attitudes into numbers on a Likert scale. It shouldn't stop us from thinking carefully about that. I mean, consider a qualitative question. Imagine you've got a simple qualitative question: where will you go on holiday? 1, France, 2, Spain, 3, other. Well, that doesn't mean that Spain is twice the holiday of France just because you've given it the number 2 instead of the number 1. And so when you see somebody doing complex statistical analysis on numbers, they've tested people's attitudes towards something, they've given it a score of 5 for highly agree, 4 for agree, 3 for neutral, 2 for disagree, 1 for completely disagree. That doesn't mean that scoring 5 is much more strongly felt than number 4. It doesn't mean that it means the number means the same thing for everybody. So what we're going to have to look at is the quality of the data, and in particular I see a lot of statistical methods being used. It's very relatively easy now to use statistical software to do complex analysis. I see a lot of work being done on numbers, a lot of complex calculations being done on numbers that frankly are not worth it. So what I want to have a look at today is having a look at the quality of data, the qualitative nature of quantitative data. And in particular, I want to look at, suppose we've got some statistics. I'm going to illustrate this with some old statistics on how many people are studying different kinds of courses in different countries at university level. So how many people are studying social sciences and law at university in a particular country? How many people are studying agriculture at university in a particular country, and so on. And the numbers are going to be represented in a bar chart, a histogram. Different years, for different numbers for different years, and you can see the first thing to do is to look at the data, just eyeball the data and to see what it looks like, and you can see immediately whether the data follows a simple trend, whether there's a simple line through it, or whether the bars are all over the place, up and down, and there's no clear pattern to where the error is. Now there are several reasons why that might be the case. Look at this graph. This graph that concentrate on the brown bars at the back. The different subjects are in different colours. The largest numbers are at the back. The brown columns are for people studying law and social sciences at university, and this particular set of data is for Albania. And you can see that the data jumps all over the place. Now there's two reasons that can happen. One is Albania might have a relatively small university sector, and so the numbers change dramatically from one year to the next. The numbers jump about because a relatively small change shows up very dramatically. Here's data, same graph, similar data, different years, students studying law and social sciences in Finland. And in this case, you can see Finland has a much bigger university sector and the quality of the data is much better. So we get an immediate impression from the missing data in the case of Albania, from the smoothness of the curve. We've got an impression of the quality of the data. We've got a lot of information on the data about the data without ever doing any complex analysis or complex statistical software packages. None of that. We can just look at the data and get a lot from it. Here's another case. This is a case that looks particularly interesting to me. Same thing as before. New Zealand, and here you can see that mostly there's a steady trend. The data is good. They've collected data from a large system, and then suddenly in 2 years there's a quite peculiar spike in the data of those sudden increase in the number of people who are studying law and social sciences, and then it decreases, it goes back to the trend it was on before. And something's going on there. There's something that stands out as it doesn't look like a random error. It looks as though for some reason there was a major change in the number of people who were studying law and social sciences. And we could then go back to the data and say, well, what's happening there? What's going on? Was there a sudden increase in the fees or a decrease in the fees? Was there a change in government policy? Was there something that happened that year? I suspect, I don't know for certain, but I suspect that actually what happened was that for those 2 years somebody decided that archaeology was a social science and they put it in there, and then a couple of years later they took it out again and they went back, they reverted to the old definition of what the different subjects were. This happens with educational data. The boundaries are not so fixed. You need to look at the detail of what the data is and where it comes from. So just what I want to say is what we need to be considering is the quality of the quantitative data and thinking about whether it actually means what we think it means. What question did they actually ask? And does the number mean something to me? My bank regularly asks me how I liked the service when I did online banking, and they say, how likely are you to recommend this service to a friend? And I put 0. I'm absolutely unlikely to recommend this bank to my friends. And they interpret that. Clearly they think that means I didn't like the service. It doesn't mean that at all. It means I don't recommend my bank to people. I mean, I don't give people financial advice that they don't want. So make sure that the questions that have been asked, without getting into the technicalities of whether an 8 on a score is twice as enthusiastic as a 4 on a score. I mean, there are a whole lot of assumptions there about how the numbers are going to work. Before we get into the question of looking at statistical methods, we need to have a look at what the quality of the data is. And I'm all in favour of quantifying if possible. We've got qualitative data, changes in kind. The Russians have 2 words apparently for the colour blue. They have a colour dark blue and a colour light blue, and that people who speak Russian draw a sharp distinction between those 2 shades of blue. I don't know where that boundary is. I would like to know. What's the wavelength of light at which a Russian speaker transfers? I could quantify that. It's a qualitative difference. I could quantify it, and it would then be more certain, more precise if I've done it properly. But just adding a number to something doesn't of itself make the data better quality. I'm going to be looking at, in a later video, at using mixed methods, using quantitative methods to explore qualitative data. And I just wanted to clear some ground by saying I don't see a sharp distinction between qualitative and quantitative. It doesn't, just because you've got numbers, relieve you of the obligation to talk about the quality of the numbers that you've got. How good are the numbers? What do they represent? Do they mean what you think they mean? Do they mean what you want them to mean?